Hello, everybody. I've been doing microservices a lot, and in the reading that I've done, some sort of received wisdom on the topic is that microservices are only useful if you are at the scale of Google, Facebook, or Amazon. And I just think that is complete, let me rephrase. I strongly disagree with that opinion. So here's the deal. Software is really easy to write, but it's hard to change. I'm certain that any of us in this room could put some code together to carry out some business objective, and the code would work, and it would work well, because we're professionals. That's what we do. But the question is, would we be able to be productive on that system 6 months from now? What about in a year? What about in 10 years? Could we bring new team members onto the project and get them up to speed quickly, or are they going to have a multi-month onboarding process during which they don't feel very productive? That's a really important question, I think. And one of the troubles is that the web frameworks that we use, they tend to push us towards optimizing for the short term. Libraries, frameworks like Ruby on Rails and Django, they lead us to monolithic architectures. And monolithic architectures have a high degree of coupling. And I think they're okay for quickly prototyping apps. They're not so bad at prototyping apps, but they're less not so good, a little awkward construction. They're not quite as good at building systems, and that's a big distinction that I would make between apps and systems. And the reason why is it's the coupling. Coupling is the enemy of change in software development. If two things are coupled together, they can't vary independently. I have to know about both of them to make changes in either one. And if I have 15 things that are all coupled together, then I have to be able to keep all of them in my head to be able to safely make changes in any of them. And sadly, we humans, we're finite creatures. That gets really hard for us to do. So who am I? I'm Ethan. There's some contact information. I do microservices a lot. I'm writing a book. I've got a mailing list if that's interesting to you. And I also have a link to the slides in the slides. That's totally recursive and meta, so there's that. And with a combination of writing and super witty talks like this one, and memes, I'm on a mission to make the monolith the architectural choice that has to justify itself. I think that in the extreme short term, monoliths would be more productive than service-based systems, even though I prefer service-based systems. But I think the problem with microservices is a lack of familiarity. And so if we could just get more comfortable with the patterns and whatnot, then we'd be more able to justify a microservice-based system, which would keep us more productive in the long term, which I think is a net win. So what's a monolith? I've thrown this word around a whole bunch of times. You should probably define what I mean by it. If you've seen 2001: Space Odyssey, that's a monolith, but that's not the kind we're going to talk about today. Here's a slide that has a bunch of different technologies, some techniques, some metrics. And if you were looking at a system, take a few seconds here and consider, if you saw one of these in a system or you didn't see one of it, which one of those kind of tell you, yes, this is service-based, or yes, this is a monolith? Just a couple of seconds for that. Now what if I told you that none of them will tell you if you're dealing with something service-based or with a monolith? Because it's not technology choice that makes that distinction. And just as an aside, what if I told you that Morpheus never actually said, what if I told you in the Matrix? Someone told me this last week and it shattered my world, so I'm bringing you all into my misery here. Well, here's the definition of a monolith that I put forward. These ideas are borrowed from a guy named Scott Velwer who gave a talk at GoRuCo 2018 in Chicago. And over on the left, we have a database table, a users table, not unlike ones I've seen in real-world projects. And on the left, we have various concerns that are in the system: payments, shipping, notifications. Let's have a look at this table. We have payment info. That sounds a whole lot like data related to payments. We have an address. That sounds like data related to shipping things. We have an email address and a phone number. That sounds a whole lot like notifications. Email address and password hash, that sounds like authentication. And role, that sounds like authorization. So on this one representation, we have the data for 5 very different concerns. That's the monolith. This one representation that all these different concerns are clobbered into, that's the essence of a monolith. And here's what happens. When you have all the data for these different concerns in one location, you're going to want to put all the code for these different concerns in the same location as well. Here's a video one of my daughters helped me make that illustrates what happens. This is called the bubble game. It's a fantastic game. And the clear circle, that's your user model. And the filled circles, those are other concerns in the system that sort of involve user data. So maybe authentication, authorization, until, wait for it. That's what has happened in every MVC project I've ever seen. Have you ever worked on the 3,000-line user model before? Yeah, that's difficult to change confidently. So, you get these systems, they're hard to work on. We go to the blogosphere for advice. How do we deal with it? The blogosphere says, just extract microservices. Okay, let's give it a shot. Here's a monolith. The green box means it's all running in the same process. Of course, there's a database right in the middle of it. I've called out two concerns, users and products. Let's pretend we're in an e-commerce system. Those lines, those are function calls or method calls if you're really into object-oriented programming. And we do some profiling and we find out, hey, users gets used a lot. Let's extract that into a microservice. Now it's in its own green box, its own process, perhaps it's on its own server, it has its own database. And we do the same thing for products, and... Wait, I heard laughter and not triumphant applause. Oh, I didn't accomplish anything. What are these lines now for running on different machines? Network calls, yes. All else being equal, what's easier to work with, a function call or a network call? Function calls every day of the week. But now I've traded them for network calls. And in fact, this is where I disagree with my own meme. I would think that if I've accomplished nothing, that would suggest that I haven't actually made things worse. But I would say that I have here. What did we actually do? Well, we just took the monolith and put it on a different server. This green box was not the monolith. That's just fine. A service-based system can run in a single process. That was the monolith, and we just moved it. But wait, there's more. If this is an e-commerce system and I'm working on products, I probably want to verify, say, that incoming requests are made by people authorized to make them. For example, if they're changing the price of something, because I don't want some rando on the internet coming in, setting the plasma TVs to 1 penny, buying 10, and then setting it back. I don't know your systems, I don't know your business model, but my priors tell me that that is suboptimal with respect to staying in business. But I get a request, I go to users to verify that it's okay, and uh-oh, users is down. Guess who else is down? Me. And if anyone depends on me, I sure hope we invested in our 500 screen because our users are going to see it a lot. Okay, so smarty pants, you ask me, what then defines a service? Well, the concept of microservices was born out of something called SOA, or service-oriented architecture. And there are 4 tenets of SOA you can read about, but we're going to focus on one of them today, and that's autonomy. I'd say autonomy is the defining characteristic of services. What do I mean by autonomy? Well, first of all, no one asks services for anything. Services do not have GET APIs. We have, architecturally speaking, components that we ask questions of. Those are called databases, and the process of asking them is called a query. They're fine pieces of technology. They're just not services. And they're not services even if we hide them behind an HTTP interface. In fact, some databases ship with, out of the box, the ability to respond to HTTP requests. They're still databases. Next up, services don't ask anyone for any information. If I have to ask you for information to do my job, I depend on you, and that's the opposite of autonomy. And then the third one, that's just a corollary from the other two. Services are oblivious to the existence of anything else in the system, and that has some really cool properties that fall out of it that we'll see in just a bit. So let's go back to this advice from the blogosphere. Extract microservices, take 2. Here's a slide full of pictures of puppies. I hope you enjoy puppies as much as I do. But it would be like this. The blogosphere comes to us and says, just extract all the kittens from this slide. What's the problem? There's no kittens on this slide. Yes, I can't extract any. Similarly, there are no services in this monolith, so I can't just extract them. Could I get this system to be service-based? Sure, but that's some significant refactoring. It's not just as easy as plucking part of it out and putting it on a different server. So then, you might be wondering, they don't ask questions, they don't get asked questions. How do they do anything? Sounds kind of like a black hole and a white hole at the same time. They do communicate, but they do so with asynchronous messages that come in two flavors, commands and events. What are those? Well, suppose I had a pen and I dropped it. Reality would register a pen dropped event. Notice that's in the past tense. As a system designer, I picked the name for that event. And I may not like that the pen is on the floor, but it's the past. I have to accept it. If I don't want it on the floor, I can pick it up. Then reality will register a pen picked up event. But I cannot just undo the fact that it was ever on the floor. Commands, on the other hand, you might tell me, drop your pen. So that's in the imperative. But the thing with commands is they can be rejected. Maybe I don't want to drop my pen, so I'll say no. Or maybe I go ahead and do it. In either case, I'm probably going to emit new events reflecting the decision that I made. But the idea is that events are statements of fact, commands are things that can be rejected. We can take this idea one step further and introduce what's called event sourcing. You're probably used to relational databases like this over here on the right that would give you the now current state of the pen. Those might still exist in our system, but they're no longer the authoritative state. We actually store the sequence of events itself. The master state that we store is these two events together. We can shape it into this quite easily. That shaping process, that's the essence of CQRS. But I actually store these logs of events. I can reshape them, and I can do this for any moment in time that I want to. So that's how they communicate with the outside world. Now, when we're talking about events, we want what are called domain events, not CRUD, not mechanical. Let's talk mechanical first. This is a JavaScript conference. We're probably familiar with the concept of events, especially if you work with Node. But we're not talking about things like button clicked or window resized. We're talking about domain events. So again, back to the e-commerce example, when you go to build a system like this, think, what are the actual business processes? What are the distinct events in the life cycle of my business that would occur? Someone might place an order. That's a great domain event. I'm sorry, that's a command, not an event, because that's imperative. But at some point, maybe we've collected their payment. So payment collected, shipping info verified, items picked, etc. When we start thinking about the system like that, though, now we're thinking of it in terms of business processes rather than database operations. And that's going to affect everything in the system, right down to the user interface. I forget who it was earlier today, but someone was talking about how user interfaces shouldn't just be like blobs of places to input data, but they should actually guide you through processes. Well, if I'm modeling my state storage this way, then it makes it really easy to do a user interface that way as well. And I would say that the CRUD operations are very crude tools. So let's look at a case study. A system I built this way for a company in upstate New York. They had an HPC cluster, that's high performance computing. If you're unfamiliar with it, just imagine banks of computers used for running simulations. It's usually programs that will span multiple cores, generate obscene amounts of data, that kind of thing. And they needed to manage access to it. Now they had an existing application that did this, but it wasn't keeping up with new requirements. And so we need to be able to do things like, if you run an experiment, you need to build your cost center for that time. It's a little bit like AWS, I suppose. But we ended up with a system that looked a little bit like this. Over here on the left, a mobile device, a browser, a cloud with a question mark that represents some of those new requirements. They wanted other systems in their control to be able to kick off jobs. And there was this API layer with its own database. And here's the basic flow of how a job worked on the golden path. User sends in a request, hey, start a job. The API is able to tell if that user can do that. And let's suppose they could. It's going to emit an event that says, hey, a job was requested. Here are the important parameters for that. And it's going to make a note of it in its local database. Because the impatient people wanting to know how far along their job is, they're going to hold down Command R, maybe even get a little bot to do that for them. We don't want to bug the rest of the system with that question. That's this thing's job to respond to that. So it has a little materialized view of the job that it keeps. Message hits the message bus. This is in a pub sub manner or publish subscribe, which means that everyone can see the event. Not everyone cares about it. I'd like to think we don't need to send you an email to tell you you just clicked a button, but I don't know, maybe that's the requirements. In a system like this, though, at the HPC clusters, they had expensive storage, which is where the jobs were actually running, and they had cheap storage, which is where they stored stuff long term. So we need to move the data out of the cheap storage into the expensive one to actually run the experiment, and then put the results back. So this move files service, it emits an event saying, hey, I've started moving the files. That goes to everybody. And the people that care about it, or the services that care about it, the components in the system that care about it update themselves the way they need to, because that's an important state transition. Oh, I see my files are being moved. This thing's actually happening. At some point it gets done, so it emits an event saying, hey, I finished moving the files. That goes out to everybody. The API notes it again. At this point, dispatch can say, oh, I can actually schedule this to run on the hardware now. And then it reports, hey, I've scheduled it to run. That goes out to everybody. The API updates again. And this got us some really cool wins. The first of them was testing. So here's the system again. From the perspective of send email, what is the difference between being embedded in the actual system and being embedded in a test harness? Nothing. You can't tell the difference because it doesn't even know any of the rest of this even exists. So testing, I don't have to spin up a copy of everything. Similarly, if you bring a new team member in, that new team member doesn't have to spin up the whole ecosystem to work on anything. Docker is a great tool for solving that problem, but it's a problem that shouldn't exist in the first place, and it doesn't have to. Next up, other teams not moving fast enough. Like we said, this involved a legacy runtime. The team that built that was a part of this project, and they didn't always get it adapted to new input as quickly as we would have liked, which gave us, the temptation to rage about that. But as my grandparents always said, why rage when you can simulate? Grandparents never actually said that. But so we could build a little component that when it sees that a job is running, it just kicks off the sequence of events that we'd see on the golden path. And the rest of the system could react to those as they're supposed to, because they also can't tell that there's no actual job being run. They just see events and then they do their thing. New features. Suppose, in addition to sending emails, we also wanted to send SMS messages. What in the system has to change to support that? Maybe a little UI work to capture their phone number if we can't already read it off an employee record. But the rest of this doesn't care. It's all left alone. It has nothing to do with sending emails, moving files, or dispatching jobs. And then the last one was we got to leverage that existing system. If part of your job has ever involved writing paychecks for people who build software, then not having to throw away something developed over 10 years by 5 to 6 people, you're gonna like that. And so that's what we were able to do with this. So that was kind of the first one of these I ever did, but my thinking has evolved since then. So let's have a look at what I would say are the major components in a system built this way. First of all, there are services, right? It's microservice-based. They are lightning bolts because lightning bolts are action-packed, and services, they're doers of things. They're action-packed. They're not representations of things. Next up, we have happy users who communicate through an application layer. That doesn't mean there's a single application. There could be more than one, but conceptually, I think of it as one thing. It's called an application because it applies services to accomplish some business end. And so requests come in from the user. The application can then emit commands and sometimes events to the message store that get picked up by the services who do their things and then write new events back to the message store. The application layer, that's what's responsible for rendering responses to the user. So like in the example of the HPC management cluster, that API box, that was the application layer, it handles rendering responses. To do that, it needs data to send back. That data comes from what are called read models, and yes, those can be plural. Probably worth pointing out that in a system like this, whatever they have for their browser, and then that whole part there is considered front end, even though that runs on a server. It's not back end stuff. But these read models, they can be whatever shape we need them to be from this message store. For example, e-commerce again, that's like the poster child for systems like this. You have to-do apps for everything else. You have e-commerce for microservices. But let's see. Right. So in an e-commerce, you might have an admin screen that has a master list of all the products. So as I'm adding products and doing stuff with their information, it might be useful to have a screen that just shows me every product in the system. Well, that could be one read model, but then maybe for my users, I want to provide full text search of all the products. So why couldn't I just take all those events again and then feed them into Elasticsearch to give myself full text search capabilities? Do whatever I want, because I have this one place where my authoritative state is. I can make as many derivations of that as I want to. But the portion of the system that actually puts that data in place, I call those aggregators. Aggregators are kind of like services, only they don't change state. They're not the doers of things in the system. They just observe events, shape them into read models that the application layer can use to render responses to the users. And then again, it's worth pointing out that none of this implies that we're talking about a distributed system. There are perfectly valid reasons to make a distributed system. Usually it's availability. If one piece goes down, I don't want everything going down. But I can do an architecture like this that runs in a single process just fine. I've deployed many of them just to Heroku. It's really easy to do in Node with set timeout, that when a function finishes, then it calls itself again. So yeah, you don't have to distribute to do microservices. And because you have distributed doesn't mean you have done microservices. So, to wrap up, what did we learn today? Well, what makes something a monolith is the data model that we use. It's the database tables, the collections that combine disparate concerns into one representation, because now that representation is not free to evolve without breaking several other places in our system. And a monolith accessed over HTTP is a monolith still. And then lastly, services are autonomous. They don't take questions, they don't ask them, and they don't even know anything else is even in the system. It's very lonely being a service. That's why we have computers do that job and not people. Where do you go from here? Well, again, mailing list, if that's interesting to you. Scott Bellware and Nathan Ladd, they're two people who work a lot in this space and have a lot of useful things to say. They're on Twitter. There's a link to Scott's GoRuko talk. That would be a good addition to this. There's a CQRS video in Node by someone named Matt Walters. It was done right here in New York City. How about that? If you want to play the bubble game, you can go do that. Really good video here. And then Greg Young is another person who writes and talks a lot about these topics. Always worth watching a Greg Young video. So there's a link to that. And so thanks for coming, and happy coding.